probably be smarter for you to come in after school and get it done. It won't take very long. It's not as a quiz, remember, a test. All right, but it is worth 50 points, so we don't want to mess around with it. Oh, speaking of that, if your name is up here, tomorrow those become detention, so get it taken care of if you intend to. Also, if you looked around the room, you'll see lots of pictures from spring break and prom. You get extra credit if you bring me a print that has math in it. So like some kids take pictures on the beach with their book, or they write math formulas in the sand. If you're not going anywhere, that's fine. Do something creative. You can still get Precal picture extra credit. I need the print though, okay? And I don't want massive prints like these. I can't do anything with prints this big. I want little snapshot prints, okay? Snapshot size. So I can put them in frames and hang them up forever, okay? All right, and we do that for the prom too. So if you don't want to do it for spring break, you can do it for the prom. Just your book has to be in a picture or something identifying you as a Precal student. All right, so here we go. Everybody knows what's going on. Here we go. Number one, convert to rectangular coordinates. Remember, this is exactly, I mean exactly what your quest is going to look like. Problems are exactly the same, just the numbers are different. So you're going to have to change to rectangular coordinates. So this is R and this is theta, and you have to find X and Y. When it says convert to rectangular, that means find X and Y. How do we find X and Y? X equals 6 cosine 203, Y equals 6 sine 203. Perfect. And then we just go to our calculator, which we all need a calculator tomorrow. Make sure it's set in degrees and type in 6 cosine negative 5.52 and 6 sine 203 negative 2.34. And that is the answer to the question. Everybody okay with that? Now, you might want to do this tomorrow too. I'm going to skip down to number 4. Because doesn't number 4 say convert to rectangular? So we're going to do the same exact thing in number 4. The only difference is the way we write our answer. Do you see how problem number 4 is written differently than problem number 1 was? That means our answer is going to be written differently, but our job is the same. This is R, this is theta. So X equals 3 cosine 127 and Y equals 3 sine 127. So I am doing exactly the same thing. 3 cosine 127, 3 sine 127. The difference is this time, instead of putting it in a parentheses, I'm going to say X plus YI. When it says change to rectangular form or complex form, it means this. Now, how are you going to keep those two apart? Well, remember, if the problem, look at number 1, the problem was an ordered pair. So the answer is an ordered pair. Here, the problem had a cosine I sine. It had an I in it. So my answer has an I in it. I found my X and my Y exactly the same way. Now, if you get those confused and you write your answer in the wrong way, if you have the right X and Y, you're going to get partial credit. you wanna get full credit, it's gotta be written like this for number 4. This is number 4. So number 1 and number 4 were both having me find X and Y. Everybody get that? Now, what are 2 and 3 doing? 2 and 3 give me X and Y. It says convert to polar. So this is my X and Y, and I need to find R and theta. It's the backwards. So I draw a picture of my X and Y. This is problem number 2. Now remember, you're finding R and theta. Isn't this R?
Yeah.
Right here's R. So what's R? The magnitude, and that would be root 13. You don't need a calculator or anything for that. Well, some of you might, I don't know. 2 squared and 3 squared, root 13. Now, this is the tricky part. You need to find this angle. And we all know how to find that, right? Second tangent, what? 3/2. Remember, tangent is opposite over adjacent, y over x. Right? Now, when I find that, which is not hard to do on my calculator, second tangent, 3/2, I get 56.31. That is not what goes up here, though. Watch it. I don't subtract anything from 270. What's happening? We're around the circle. That's 180, and I'm going 56.31 more.
Why is it not? Oh, never.
The angles always start here and always go this way. Always. The only time we do anything different is if we're doing an airplane flying or something like that. We're not. This is a straight math problem. So what do I have? If I add 180, what have I got? 236.31. That is your theta.
Wait, I missed how we got the square root of 13.
You just do
A squared plus B squared equals C
yeah.
squared. Pythagorean theorem. Now, number 3 is asking the same thing. Convert to polar. Convert to polar. So I have to find R and theta for number 3. I'm going to do everything exactly the same. What's my X and Y in this problem? X is -4 and Y is 7. I'm going to find R and theta exactly the way I just did it. So what's my R? Robbie, what's my R? This is my R.
calculator, Robbie.
65.
Square root of 65 is your R. Now I need my theta, and I'm going to find it exactly like I did this one. I'm going to second tangent 7/4. Take or leave the negative, I never use it. So I got 60.26. Now make sure you're doing 7/4. It's opposite over adjacent. It's y over x, right? Second tangent. That's not theta though. This is theta. How do I find it? 180 minus it. So that angle is actually 119.74 if I subtract it right. Now how am I going to write my answer? Last time I wrote it in parentheses as an ordered pair, but my problem was that, right? That was my problem. This time it has an I in it. The problem has an I in it. It's still X, it's still Y, it just has an I in it. So when I write my answer, it's going to be root 65 CIS 119.74. Remember, in complex form, you have x plus yi. In polar form, you have r cis theta. Those are the I forms. Then you have the ordered pair forms, which are just x, y, r theta. So, if it's an ordered pair, we're going to answer as an ordered pair. If it's an I, we're going to answer in whichever one is appropriate for the problem. So problems 1 and 4 kind of go together, and problems 2 and 3 go together in terms of the work that you do, the math that you do. We okay with that? All right. Now we're going to convert to a polar equation. This is number 5. We're going to convert to a polar equation. Now, Eric, this is what you asked me about in that one homework problem. Homework, by the way, is due tomorrow, remember. How do we do this, Eric? What do we do to convert to a polar equation? We take out the x and replace it with our cosine theta. The y becomes our sine theta, and we're done. That problem takes 3 seconds to do. If you are going to write it as a polar equation, you got to get rid of the x. And we know x is our cosine theta. So there we go. That's it. Now this one is a little bit different. Right? All right, so who remembers how to do this one? This one takes a little bit longer. It's got some steps involved. Emily?
Can you change sine into y over r?
Yep. Whatever, now the test, that may be something different. But whatever it is, change it into its definition. So sine is y over r. If it were a cosine, it would be x over r. If it were a secant, it would be r over x. Whatever that function is, change it. Now, no matter what it is, you're going to change it into a fraction, because they're all fractions. Opposite over hypotenuse, hypotenuse over adjacent, whatever. They're all fractions, right? So we got to get rid of the denominator. So we're going to multiply both sides by r. You're going to multiply by whatever your denominator is. Okay? So what do we end up, oh, wait a minute. What's r squared? X squared plus y squared. Yep, the Pythagorean theorem. So there is the answer to the question. Now, every time you do one of these, either that exact thing is going to happen, or if the problem happened to be this, and we start the same way. Cosecant is reciprocal of sine, so that would be r over y. And then we multiply, this time by y. And then something different happens. Instead of getting r squared, you get an r on both sides. So we can divide them out. And that would be the answer. So one of those two things is going to happen. You're either going to get an r squared, which you're going to change into x squared plus y squared, or you're going to get an r on both sides that you're going to divide out, get rid of that way. All right, then number 7 says we want to multiply these two numbers together. Now, this is super simple, but you gotta remember the rule. There's a rule for it. How do we multiply numbers in polar form? What is the rule for that? Multiply the r's, the numbers in front, those are the r's. Multiply the r's and add the angles. So the answer would simply be 30 CIS 123. And then when we divide, what do? Divide the r's and subtract. So it's going to be 5/6. 5 divided by 6, 5/6. CIS negative 77. Now, if you leave that, you're going to miss a little fraction. It's going to say like minus an eighth or something. Because what about negative 77? It's negative. So we add 360 to it to get a positive coterminal angle. And what is that going to be? 283. And that is the that is the answer that's going to get full credit. All right, number 8. Okay, this is a big one. Okay, so negative root 3 minus I, and we're raising it to the 6th power. Okay, who remembers what we do to start? We draw a picture of it because we want to change this into CIS form. So we need an R and we need a theta. So we're going to draw a picture of it. So this is your X. There's like a negative 1 there. That's your Y. Okay? So now what's our hypotenuse, our R value? 2. Those of you that are in the dark on that, square root 3, it's 3. Root 3 squared is 3 plus 1. Remember, you will have a calculator, so if you need to do it on the calculator, do it on the calculator. That's 2. Those numbers should look familiar to you, so you might know what this angle is, even without a calculator. But again, you have a calculator, so you could do what? Second tangent 1 over root 3, and it should say 30, but be careful. Your actual angle is not 30. Your actual angle is 210. So your number is 2 CIS 210. This is your R. R is 2. And theta is 210. Now, we're going to raise that to the 6th power. So what does the rule say? Take 2 to the 6th and take 210 times 6. Remember that rule? There's lots of rules to know. So 2 to the 6th is 64. 210 times 6 is 1260. Now this is another case where you're going to get most of the credit here. But what do you notice? 1260 is huge, right? So we're going to start shrinking it down. Just take out the extra revolutions, take out the extra 360s, and that's going to go down to what? 180? And that is the full credit answer to the problem. That problem is probably the longest one in terms of steps and things that you have to do. All right. Okay, so now we're going to plot a couple points. and then we're gonna do a sketch. So this is exactly what you're gonna have to do tomorrow. Okay, so here we go. We're gonna plot the point 3 comma 5 pi over 6. And this is exactly the graph, you know, the grid that you have tomorrow. Notice it's in degrees, so you probably want to change that radian measure into degrees, right? So you have 1 pi is 180, divided by 6 is 30, times 5 is 150. So we're plotting 3 150. So we're going to come over here to the 150 line and count out 1, 2, 3. So there's point A right there. 3 circles out on the 150 line.
Do we have to label it or anything?
It says label them A and B. All right, then we've got negative 5, 45. Now, that's going to go on the 5 circle. But because that's a negative, there is no negative 5 circle. I have to flip it. So I'm going to plot it at 5 where? 225. How did she get 225? She flipped it to the opposite side of the circle. Now think about that. If you're flipping it to the opposite side of the circle, aren't you moving 180 degrees? So we're going to go on to the 225 line, 5 circles out, there's point B. Okay, and on the test it'll be just like it's been on all the practice. It will be an angle that's marked. So I'm not going to give you some freaky angle like 117. It's going to be something that's marked on there already. A line that you have, okay? All right, now get your calculators out and see if you can sketch R equals 4 sine 3 theta. You have to be able to do this by yourself. Make sure when you transfer it to your paper that you have it the right size. Is that what yours looks like? Are your leaves 4 units long? Make sure you got them coming right out here to circle number 4. These leaves are 4 units long. You got 3 of them, I hope. That's what it looks like. Doesn't have to be perfect, but it has to be the right shape and the right size, okay? Any issues? Okay, so that practice quiz is done. So what on there is there anything on there, any kind of problem that you're still a little bit shaky on and we need to do another practice? Liam says, no, move on, I got this. Anybody need extra practice on any of it?
Can you do another example like number 6 where it says convert to a rectangular?
Yep, I already did 2 of them, but I will do another one.
Hopefully.
Hang on. We're practicing for the quest. I want you to pass it. Alright. I can't remember, was it sign before? Alright, so here we go. Here we go. If we want to change this equation into a rectangular equation, the first thing we have to do is get rid of that. So r equals 4 times y over r. Right? Then what? Times by r. And then this is where one of 2 things is going to happen. Either you're going to have an r squared, which is what we have. And what's r squared? X squared plus y squared. Or, if the problem had been this, secant is r over x. So when I multiply, I'm going to have an r on both sides. So either when I multiply, I'm going to get an r squared, and I change that. Or I'm going to get an r on both sides, and I divide it out. There's only 2 things that are going to happen.
For the secant one, would it just be more steps if you did 1 over x over r?
Yep.
So you could just
Yep.
flip it?
Yep, it's the reciprocal, so it's easier if you just flip it, I think. All right, here's what I'm gonna do then. I don't know how much time we have left, I can't remember. All right, so you got a few minutes, you can either work on homework